All right, over to you, Zelalem.
All right, thanks, Joanna. So hi, everyone. For those of you who don't know me, I'm Zelalem. I work in the TFA team at ARM. So today I'll be presenting about the realm management extension support in TFA. So this is so we have a bunch of patches at tf.org regarding the RME extension that we expect to make it into the V2.6 TFA release. So I'm going to give you kind of a context into what the changes are about. I'm not going to go into detail on any particular patch, but I'll try to give you a context on, if you want to review it, then I think it would be much easier once you look at this presentation. So yeah, so this is the agenda. So I will first give a brief introduction into ARM confidential compute architecture and realm management extension, RME. Then I'll talk about the changes we have in TFA to support RME. Okay, so ARM CCA. So I mean, you might have heard about ARM CCA. It's a new confidential compute architecture from ARM. So it's part of the ARM v9 architecture. So it is designed for virtualized environments. So what it does is it allows you to create virtual machines and execute them in a hardware-backed secure execution environments called realms. So any code and data that's executing in realms is protected from observation or modification by privileged software such as hypervisor and host OS. So it provides both confidentiality and integrity protection. So the realms are supported at the VM level, so they are basically treated just like any other virtual machine. In fact, the hypervisor does the scheduling and the memory management. So that means there is little change within the VMs to use required within the VMs to use this architecture. Another feature of this architecture is the platform and realms are attestable. That means realms can request attestation, to make sure that they are running on a genuine platform and their state is not tampered with. So it also provides this attestable feature. So yeah, so before showing you what the architecture looks like, I think it helps to basically compare it with trust zone architecture. So it's a major change compared to the trust zone architecture. So I'm going to start with just a quick recap of what the trust zone architecture looks like. I'm sure all of you here know what the trust zone architecture is. So in the trust zone architecture, we have two physical address spaces and two security states, secure and non-secure. So to the right, as you can see, we have the basic trust zone software architecture. So at the bottom in the AL3, we have a monitor that's also running in the secure state. At AL2, we have an unsecure hypervisor, and if the architecture supports a secure AL2, we'll have a secure partition manager. And in AL1 we have the kernels, and on top of that we have apps. So we have the VM in AL0 and AL1 and unsecure. So with the secure, we can have trusted OS, and on top of that trusted applications, or we can have secure services managed by the SPM. So yeah, so this is what it looks like. So so there is an isolation between secure and non-secure states, which is enforced by the trust zone controller. So in this architecture, if you are in the non-secure state, you can only access the non-secure physical address space. But if you are in the secure state, then you can access both the non-secure and secure. So yeah, so this is just a recap. So so I guess one characteristics of this architecture, this one is important when you compare it with a new architecture. So there is no architectural mechanism to dynamically move memory or devices between secure and non-secure. So typically the secure memory is carved out at boot time, and you can't really expand that region once you put. So this is an important characteristics. So the new ARM CCA, so RME. So RME is basically the hardware support or the hardware support for the ARM CCA architecture. So in the new architecture, we have two additional physical address space and security states. They are called the root and realm. So now, as you can see here, the EL3 will have its own security state. It's called the root security state. So the monitor will run in the EL3 state or in the root world. And we have additional state called realm, and it also has its own physical address space. So realm, and there is a new firmware at realm EL2. It's called the realm management monitor. So the realm VMs run on top of the RME. Yeah, so that's basically the major change with the TFA. So in this architecture, secure and realm are mutually distrusting. Sorry. So the access rules are not shown in this table. So if you are in the non-secure state, similar to trust zone, you can only access the non-secure physical address space. And then if you are in the secure, you can access non-secure and the secure physical address space. If you are in the realm state, you can access non-secure physical address space and the realm physical address space. So if you are in the root, then you can access all address spaces. So that's the major difference. So if you have any questions, please feel free to stop me. Yeah, so the physical memory access, the table that I showed you or the policy that I showed you is enforced by a hardware granule protection check. So this is done inside the MMU. So as you can see on the right, there is this granule protection check step at the end of address translation. So at the end of the address translation, you might have just a single stage address translation if you are in L2 and L3, or you might have two-stage translations. So at the end of this address translation, the physical address is checked against what we call a granule protection table. So basically, the granule protection table describes a physical address space assignment for each physical address or for each page or granule. So this granule, the MMU uses this table to check whether that access is allowed. If that access is not allowed, then a granule protection fault is raised. Yeah, so we have this additional data structure. Okay. Another major difference with the trust zone architecture is that now memory can be moved between physical address spaces. For example, you can move a page or a granule from the non-secure into the realm world dynamically. So this is called memory delegation and the reverse process, is called undelegation. So this is a new important difference with Trustzone. Okay, so like I mentioned earlier, so now we have a new firmware called Realm Management Monitor. So this firmware is used to manage execution of Realm VMs, and it interacts with the hypervisor and also the Realm virtual machines as well. So there are two interfaces, one with a non-secure hypervisor. It's called the Realm Management Interface. So like I mentioned earlier, the hypervisor still does virtual machine creation, population and execution. It does the scheduling, it does memory management, but it needs the help of the RME to accomplish those tasks. The RME has access to the Realm world, so and the hypervisor doesn't. So in order to accomplish these tasks, it needs the help of the RME. So this is done through the RME interface. It's an SMC interface. Also, there is another interface. There is a direct interface between the RME and the Realm or the Realm virtual machines. So this interface is used to give services such as cryptography services. For example, during attestation, the Realm state can use this interface to request attestation reports. Okay. So this is a very quick introduction to the RMCCA and architecture in RME. So now I'll just talk about what we have in TFA to support RME extension. So I guess in the RMCCA or the AL3 firmware has some responsibilities. So this include loading and running the RMM firmware, also switching between the different worlds, and it also does the management of the GPT, right? So the GPT is only accessible by the AL3 firmware. So I'll just talk about the changes we have, starting with the boot changes. So this is a typical boot flow with SPM. So this is what we have currently, just a very simplified view of what the boot flow looks like if we have an SPM. So in this boot flow, so we start with a secure ROM. The secure ROM loads and verifies the secure boot firmware for BL2. So BL2 typically runs at secure EL1, right? So BL2 loads and authenticates the BL3, BL3.1, BL3 monitor, SPM, secure partitions, and the normal world boot firmware BL3.3. After that, it will transfer control to BL3.1. Then BL3.1 will initialize the SPM, and SPM initializes the secure partitions, and we come back to the L3 monitor. Then the L3 monitor gives control to the BL3.3 or the normal world boot firmware. Then this boot firmware will load and run the Linux kernel. So this is what it typically, I guess, looks like today. So now we have a new image RME. So we have some changes to the boot flow. So one of them is, so now AL3 is always has to be in the root world, right? So so now we have a new change where the BL2 has to run in the AL3 as opposed to AL1. We already have a build option in TFA. It's called BL2 at AL3, so it allows you to run BL2 at AL3. However, we didn't use this one because this option assumes that you don't have a boot ROM. but we have a boot ROM in the RME boot flow. So we had to create a new separate boot flow for RME. Another change, as you can see here, is we have a new image that needs to be loaded, RMM. So it's loaded by BL2, and it is initialized after, if you have an SPM. We don't necessarily need to have SPM. So if you have SPM, it's initialized after the SPM. So these are, what the good changes look like.
So quick question, right? Does the ordering matter, in terms of initializing SPM versus RMM? Could it be the other way and everything would still work?
I think that's a good question. I think it shouldn't matter. I don't think it should matter. But does anyone has an opinion? I think some of the folks here might have worked on that. So I don't believe it matters. Yeah.
Okay.
I guess it's if the SPM has some interaction with some of the trusted compute base and it needs some initialization, it would be useful to have that initialization done by the secure world before RMM comes along and tries to interact with that trusted compute base. But currently we don't, at least on the code that we are prototyping, we don't see a strong dependency there. Yeah.
Yeah, so I guess maybe in the future, yeah, right. Okay.
Okay, thanks.
Okay, any other questions?
Can you tell me what is the difference between root SRAM and secure SRAM?
So we have a new world, right?
Okay.
So we have this one is in the root world, and the other one is in the secure world. So I guess previously we just have secure SRAM.
So is this a different physical device?
Yeah, it's mapped to that. So the SRAM is mapped. Part of it is mapped into the root world, and part of it is mapped to the secure world.
Okay, thank you.
I think the question was whether it needs to be physically different.
Yeah.
Right. It can be the same SRAM and you just partition it via your MMU, or you can have it physically and it wouldn't matter, right?
Yeah. So it can be the same SRAM. Yeah.
So the MMU protections mainly apply to the DDR, and the SRAM is considered a peripheral, which needs to be protected by a peripheral side filter. So typically, what I understand is when they build the system, the root SRAM would be protected by a peripheral side filter, which only allows root world accesses to go through. Which means that we can only ever execute software which is meant to run at root world from this root SRAM. It is possible to partition it in hardware, having another filter for another SRAM, which is for the secure side. But the FEP that we have available externally, the RME enabled FEP, what that does is the SRAM that's available on FEP, when RME is enabled, that becomes a root world only SRAM. And the TZ DRAM, which is available on the FEP, that becomes secure only TZ DRAM. And the DDR can, of course, be dynamically partitioned using the GPT hardware to belong to any one of the address spaces. Finally, it comes down to the system, how it gets built. Yeah.
Correct, but I guess it doesn't matter if you don't have this peripheral side filtering, right? Because you still have you still have the GPT that would do the same same protection, right? Ignoring DMA and things like that, right? If you've got the CPU side MME protection, then you don't really need the peripheral side filtering, right?
Yeah. So it depends on the GPT tables being set up, because we need the GPT tables to be set up and GPC hardware enabled to have this protection enabled. So if we want this root SRAM to be protected from reset, then there is a tiny, there's a small window where GPC is not enabled. And yeah, so that would be the gap over there.
Okay, thanks.
A question on the loading part. I think previously on slide 10, I guess, we talked about EL3 loading the RMM. And I think at the start of slide 14, you said that something about BL2 in EL3 and that not working out. Can you please explain that part a little bit? Again, I just want to understand, what were the limitations and why you chose this path.
I think you are talking about this slide.
Yeah, this one and slide 10 both.
Slide, okay. Slide 10 or?
Yeah, slide 10, bullet point 1.
Sorry, can you say that again?
Slide 10, bullet point 1, where you said loading.
Oh, okay. Oh, yeah. So, yeah. So I'm just saying, what the responsibility is, loading and running RME firmware, right? So this is just a generic description of what the AL3 firmware is supposed to do, I guess. Does it make sense?
Right. So you are not saying, so this is not for BL31, but any.
So when I say, okay, so I guess when I say AL3 firmware, I'm talking about the BL1, BL2, and BL31, right? All the firmware that runs inside in AL3.
Okay.
Yeah, so that also includes BL2. Does that answer your question?
Yeah.
Okay. Okay, any other questions? All right, so this is, I guess, the change in the boot flow. So we also have other changes, other enhancements. One change we have is we now have a new CPU context for the Realm world. So we made some changes in that context management. Another change we have is, so right now we have 2 additional worlds, right? So we enhanced the translation table, the V2 version translation table, to include the root and Realm world attributes. We also have other changes such as support for RME image. For example, we enhanced the FIB tool to support the RME image. And we have a new build option. It's called enable RME. So if you want to enable the RME feature, you set this enable RME to 1. So yeah, these are some of the enhancements that we have. So in addition to these enhancements, we have new additions. We now have a new dispatcher, the RME dispatcher. So it's a new standard service that handles calls from the RME or RMI and RSI, should include RSI as well. So it handles SMC calls, RMI SMC calls. Yeah, we also have a GPT library. So like I mentioned earlier, the AL3 manages GPT. Yeah, so we have a library that enables and initializes the GPT, and we also have support for granule transitions. Another action we have is test Realm payload, TRP. So this is a small test payload that implements the RMM. So we use it to test the.
I'm on a call.
Sorry, is there a question?
Oh, sorry, my mic was open.
Oh, okay. So yeah, so we have TRP. So we use this. So this is a very small test payload that implements the RMM functionality. So we use it to test the interface, the SMC interface. So right now it supports granule transitioning granules from non-secure to realm and vice versa. So we have these changes. Another change we have is a platform changes. So currently the only supported platform is a FVP platform. So we need to have a new, I guess, carve out for RME support. So here I'm comparing what we currently have and what we will have when we enable RME, both for the trusted SRAM and the DRAM. So in the trusted SRAM, we have a new data structure, L0 GPT. So I didn't talk a lot about the GPT. We'll probably have a presentation on that in the future, but the GPT is it's a two-level table. So we have the level 0 table GPT and the L1 table. So the L0 GPT is stored in the, I guess, trusted SRAM. So we have one carve out for it. So that's the only change we have in the trusted SRAM. And we have two additions in the DRAM. So we have the carve outs for the realm world. For this is used by the RME. And we also have a carve out for the L1 GPT. So the L1 GPT is in the root world, and the realm will be in the, I guess, the realm world or physical address space. Yeah, so we have this.
Sorry, quick question. So the left side, the green diagram is without the enable RME option, and the right side, the green is without and blue is with the enable RME option. Is that how I should read the slide?
Yeah. So this one is for trusted SRAM. Yeah, this one is without RME. This is with RME.
Okay, and it corresponds to the build option, right?
Yeah.
Okay.
Yeah. So I think the coloring, I think this will help you. The key is, so the changes here we have, this one is in the secure physical address space, right? Without RME, but now it will be in the root physical address space. Does it make sense?
Yeah, maybe on the right hand side, the SCP-TZC and AP-TZC might be green, right?
Sorry, the SCP-TZC.
ICP, I don't know, but at least AP-TZC might be a green color.
Okay. You mean this one should be green?
Yeah, well, it's a question.
Oh, okay. I think it should be root, right? I think it should be root. Okay. Yeah.
I think it's meant for the secure world usage. So it would probably be green. Yeah, we need to. Okay. So currently the SPM doesn't use that region. So that's why probably we haven't noticed. But if the SPM is in DDR, that would be the region where SPM would be loaded onto. So it would be green color. Yeah.
Okay. I think that's my mistake.
And what do we expect for this SCP-TZC region? Does it remain root world or root path?
I believe so, right? I think I'll have to double check that, but I think it should be in the root.
Okay.
So the FVP doesn't use that region. This is mainly for systems with SCP. So possibly this, it would be part of SCP configuring the DDR, setting up the DDR parameters. We haven't really figured out which world it should be. Probably root, or it would be access any for anyone to access, and SCP can access it to configure the DDR. Yeah.
Okay.
Yeah, it looks like any of those things that says TZC should probably be green.
Yeah, I think that's
by definition. It's trust zone controller. So
maybe not the EL3 TZC because that's used by BL3N, which is now root. So by legacy, it was called EL3TZC, but it
EL3, yeah. So I think the naming can be confusing, you're right? So if it's in EL3, then it should be root. If it's used by the secure, it should be, I guess, in the secure. Yeah. I think the naming can be a bit confusing. I agree. Okay. Right. So we also have TFA tests in. So we have some tests that test granule transitions. We have a single CPU and multi-CPU granule transition test in TFA tests. So we use this setup to do the test. So in the real model, we use the TRP as the RME, and TFA test as I guess an insecure component. And we also, we can also boot with half-VM as a SPM component, and we basically test this interface, the RME interface. Yeah.
TRP is test realm payload. Is that correct?
Yeah. It's a TRP, the test realm. Yeah, test realm payload. Right. So yeah, we have these changes. So I have a link to all the patches if you want to take a look at them. Yeah. So I guess this is the end of my presentation. So if you have any questions.
So
I have
couple
a
of
question.
questions.
Okay.
Sorry, go ahead.
Go
You
ahead,
first. Okay.
Okay.
It's not completely clear to me what the application of this realm world is. So what kind of thing would I want to run in the realm world that I can't just do in the secure world?
Okay, I can try to answer it. I'm not an expert on this, but I think the difference is, so I guess the RMCCA, it supports at the support is at the VM level, so you can basically run any virtual machine that you have right now. So the difference is if you run it in the realm, you get protection from the hypervisor and the secure wallet software, right? So I guess currently it doesn't. I don't think you can do that in the trusted. In the trust zone architecture, right? The trust zone architecture, you can basically get some services from, for example, trusted OS and things like that, but you can't run a whole virtual machine inside of this protected environment. Does that make sense?
Okay, yeah, then it makes sense. Thanks.
So I was going to ask if this FVP is available publicly. I thought I heard someone say it's available publicly, right?
Yeah, it's available publicly. Yeah.
Is it just the FVP v8 AEM that I need to download?
Yes. So I think on one of the patches we have a documentation on how to build and run it on FVP. So I think there is a link in there. Yeah. So there is a guide on how to do that. Yeah.
Okay, great. And is there any plan for this was answered in Linaro, I think, but I can't remember. When is the real RMM expected to show up in public?
I think so. We can answer that.
I think the specification for RMI is expected to reach beta by mid next year. And once it becomes beta and available externally, that's when we can start, making this RMM prototype implementation also available. Yeah.
Okay, so the RMI is not yet public, right?
The RMI commands, the specification would mandate how the RMI commands and how it should interact with the RMM. So that specification is not public yet. It's expected to reach beta only mid next year.
Okay, Thanks.
So just to clarify on what Varun asked earlier is the current architecture, the BL2 runs at EL exception level EL1 in secure mode, but with the RMM coming along, it will be running in root mode. That's the main difference was, right?
Yeah. And I mean, root means, I think the new architecture root is the same as EL3. So
right. So earlier we are not running at EL3 for loading bit, except for that BL2 at EL3 thing.
No, we are. I mean, if you enable RMM, so the BL2 will run at EL3.
Yeah, that's always the case.
Yeah. Yeah, that's a new change we have. Yeah. So what I was trying to say was we could have used, that option that we have, but that option, assumes you don't have BL1, right? I think it's for systems that don't have BL1, but we have BL1 in RME, so we had to.
So did you extended that macro, the BL2 at EL3 feature, or you have done something entirely different?
No, it's entirely different. It's a new pass. It's basically a change on the modification on the current pass we have, right? The BL1, BL2. So it's completely different from that option.
Okay. Yes. Okay.
Yeah, Zelalem, I have a related question on. So how different it is from BL2 at EL3 then? Means you said something difference is there. So can you just on high level tell what are the things newly done for BL2 at EL3 in case of this case, RME case?
Yeah. So like I said, so we need BL1. So BL1 has to do some initializations, right? So we have BL1 here, but if you use the BL2 at EL3 option, it does some of the initializations that are done by that were supposed to be done by BL1. Does this make sense? So we don't need, So that's basically, the change, right? We don't need those initializations.
Okay, yeah. So it is stripped some initialization and then okay, got it.
Yeah.
Thanks.
Quick question. So I understand the motivation behind realms is to just operate boot VMs and that are safely isolated from non-secure world and secure world. Does it mean we can just use the existing image of VMs to in the realms?
So no, I think you need some modifications. I don't think you need modifications on the application side, but at least in the kernel side. So I think I showed the diagram here. So there is this interface. I think there is this RSI interface. So I think that the new kernel needs to be aware of this interface, right? So it has to be aware of this service. So you need some modification in that area, but I don't think you need modifications in the applications, or at least the modifications are minimal.
Okay. So I think
Sorry, go ahead.
Yes. So I think the eventual goal is, the Linux kernel can dynamically detect whether it's running at non-secure world or running within the realm, and it can dynamically choose what needs to be done. So effectively, you have one image which is capable of running in non-secure and realm, and it would detect dynamically, or it would have some DT information encoded, which would allow it to modify some interactions with EL2 and with the hardware. And effectively, the eventual goal is we should be able to run the same image in both the worlds. But it's a journey, I think. Yeah.
Okay.
I was about to say.
Go ahead.
Sorry, go. No, I was going to say the RSI is only required if you want the realm services like attestation and things like that, right? Because in theory, you can just take a Linux kernel, run it in realm, and if it does not need to, interact with normal world, then it can be completely unmodified, right? Or is there no situation where you can run completely unmodified?
Yeah, I think if you want an interaction with non-secure world, I think you might need that interface. I'm not exactly sure, but it's not just the attestation.
Right. What I mean is, if I don't need any interaction with the normal world, I should be able to run, say, a Linux kernel directly in a realm, and it wouldn't know the difference between a non-secure VM or a realm VM, right? You only need it if you care about the other guarantees that realm provides.
But actually, you need that to run some workload, right? So you need at least some kind of buffer between realm and non-secure to communicate results, for example. I'm not sure I see how it makes sense to run something fully standalone in a realm, but yeah, I may be corrected.
Yeah, I'm not exactly sure about that.
Yeah, I think the deployment model would be the application in the realm would interact with the non-secure application through some VirtIO channel setup through some application defined mechanism, and both of them can exchange information through that VirtIO channel. And but I'm not too clear on how this will get deployed. Okay.
Any other questions? Okay. Yeah, so please do go look at the patches. And yeah, thank you for attending the presentation. So Joanna, I'm gonna pass it back to you.
So guys, so we thank you, Zelalem, for that. As I mentioned, the video and the slides will be uploaded in the coming 2 or 3 days once I get around to doing that. What we do have is a little bit of time left. I've got nothing particular. What we normally do is, let me share a screen. I can find the right screen. I can't. That's not good. That's what I need to share. Yeah. So what we haven't done for a while, because we know these sessions normally run up to the wire. But part of the format of this meeting is also to discuss anything on the last few weeks, or the last few weeks on the mailing list. And I haven't been too active recently, but does anybody have anything that they feel they want to talk about live here today from the mailing list? Okay, not hearing anything. So this was the opportunity to do that. It doesn't sound like there's any other business to talk about.
I have a question that was not on the mailing list.
All right, what was it?
So I've seen a lot of CPU support being upstreamed. For example, Haze and Demeter and other CPUs. So does that mean the simulation models will also support provide these CPUs, and it will be available for verification or is it already available?
So sometimes you're talking about the FVPs and things. Sometimes they're a little bit behind. So they're produced by our DSG group, and they go through verification and quality checks on the models and everything. And so though they're available for us internally at the moment, such that we feel comfortable upstreaming the new CPU support, we have to wait on our DSG folks to release them, and that can take a few weeks after the support is available upstream. But the intent is, as soon as they're made available to us and they give us the all clear that we can make them public, as soon as they make them public, we will then add support for them in the OpenCI. But we have to wait at this time for them to make them public. even though the actual TFA support will be upstream prior to that. So the short answer to your question is no, not at the moment, but it'll be coming once the DSG group release them.
Okay. And I think in the past, not in the TFA forum, but in other meetings, we've talked about the erratas for different CPUs. So is that something that the TFA team is still looking at, publishing all the erratas for all the CPUs, or is it an opportunistic project?
Maybe you're on the line, Bipin?
Yes, Joanna.
Yes, so maybe you want to give an overview of our sort of errata strategy.
Yeah, so currently what we are supporting is actually the partners supported course, especially the ones that are actually across multiple partners. We typically don't support ELP cores and also AE cores at this time. And as you know, the errata support is actually restricted to CADB erratas for CPUs, unless there is like special request on any special CAD-C erratum as requested by partners. And we, as of now, we prioritize erratum that are actually available for like cores that are public, and also where the extents are actually published on the developer website. So yeah, that's pretty much what we follow at the moment. So are there like any specific cores that you are actually having in mind?
Nothing specific. I mean, whatever we find for the course that we use, I try to push the mitigations upstream. But I just wanted to understand, the overall strategy from.
Yeah. In terms of overall strategy, as I mentioned, we try to provide support for all cores other than like the ELP cores, or actually at the moment we are also not supporting the AE, the automotive extension cores. But other than that, we try to be in sync with other cores.
Do you want to talk about the different categories of erratas and what our strategy is?
Yeah, actually, we had a earlier presentation on this. Maybe there is a recording as well. But the three the main categories are like Cat A, which is actually not something that we can fix, and hence we don't have any fixes for the Cat A. The Cat B has Cat B and Cat B rare, so we try to support all Cat Bs and not the rare unless there is request. And similarly, there is a lower priority Cat C, which we only support based on like partner request. And as you know, I think these are the A, B, and C are actually like the erratum impact, with A being the highest impact and actually the Cat C being the lowest. And in many cases, actually the erratums may be like simple chicken bit fixes, or actually like code sequence that trigger certain actions within the hardware. So most of which are actually supported in like EL3, which we kind of support. But there is also some more complicated erratum that may be spread across multiple components like kernel or firmware. And there is actually a new interface, errata ABI interface, that is being proposed, and in the works. The spec is actually kind of final, and there may be a interface that is supported, which helps the kernel to probe in terms of what erratum is actually supported, like for a specific core and specific like version of the CPU. And that's actually something that is actually coming up.
I suppose the other important thing, which I'm sure you all know, it that our atoms are tied to hardware faults and hardware design faults and things like that. So what we provide in TFA is mitigations to them.
Yeah. And soon in the future we may also like upstream some cores which are actually ELP cores, and the reason being actually they will be actually in the total compute platforms that actually ARM is coming up with. And so this may be an exception where actually typically the ELP core SDNs are not available in the developer.arm.com. So that's actually something that we discussed recently. So this is an exception I just wanted to bring to notice. Yeah. Any other questions? And yeah, if you want to go over the erratum process which we presented earlier, we can actually do that.
Yes, this page is the tech forum, and I'm sure down here somewhere is the session that I'll probably find it eventually. Yeah, we've been doing this for quite a while now, so there we go. There's a session there from well, about just over a year ago where Bipin went through. So you got the presentation and the video recording, and lots of other subjects. I'm always, if anybody in the community has got something they want to present here, please reach out. I know, we've had some, partner presentations previously, but do reach out to me. Joanna.Farley@arm.com if you've got something you would like to present to the community, the TFA community. More than willing to host you, as I probably saw in the as we saw, occasionally I cancel the events because I've got nothing to present. So it's nice to have some more things from the community if possible. Otherwise, we will try to do something as and when we've got work ongoing, and present to you guys, and give you updates of what's going on. So we're more or less at the top of the hour. So unless there's any final thoughts or final comments from anyone, I'll stop the meeting and stop the recording. So I think I'm still recording. And thank you for everybody's time.
Thank you.
Thank
Bye.
you.
Thanks.
Thanks
very much.
Bye.
Thank you. Bye.
Thank you. Bye.